Good evening, students. I wanted to recap activity number one, build a table, in case you are absent or need a recap for reviewing for the test. So you should complete this document called Build a Table in you being able to describe patterns. And most importantly, I want you to complete question number four, predicting the missing elements. So in order to do that, you might need to review this entire activity. So unit two is about atoms and the periodic table. Here on the left, there's a picture of the atom, maybe something you've looked at in middle school and some of the terms you've seen before. And below, there's some graphs, and we're going to be doing a lot of graphing and plotting throughout this semester with us. So what is material science? So here's some elements you do know. Think, what properties do they have that make them useful in society? So here's the activity for today. The periodic table card sort. In Google Slides, you can access these cards that have element data on them. For example, the element name, physical properties, if it's a solid, liquid, or gas at room temperature, what type of element it is, a metal, the atomic symbol, Mg for magnesium, valence electrons, those two little sticks we see sticking out, the atomic radius, so how large that atom is, where the compound is found out, and the reactivity. So at this point, you should be able to grab your cards from the Google Slides and arrange them from smallest to largest. So on the virtual version of this activity, you have these cards that you can actually drag and drop from smallest to largest. Your step is to then determine any patterns that you recognize in the periodic table. For example, something I notice is that beryllium does not react with water, magnesium slightly reacts with water, calcium reacts with water, and strontium reacts vigorously with water. Another pattern or something I notice that are the same is that beryllium chloride, there are two chlorines for every beryllium atom. There are two chlorines for every magnesium. There are two chlorines for every calcium. And there are two chlorines for every strontium. So these are examples of patterns I could identify within the activity. So as you progress in the activity, you should now be able to start creating a larger periodic table and identify any patterns you notice across the periodic table or down the periodic table. So I will be creating a periodic trend where I am grouping the cards based off of how many sticks there are. So in the first column, there should be one stick. In the second column, there are two sticks. And something that I immediately identified is that as you go from left to right, not only do the sticks number increase, but the size gets smaller. Atomic radius. And I noticed that the property decreases as you move from left to right in a period. After the end of this activity, you should be able to use the patterns you created from your periodic table, which doesn't have to look like my periodic table, but you should be able to use the table you created to predict the missing elements. So use these patterns we have identified to make a prediction of the missing elements, and you should be able to fill out all the properties as you saw in the model cards to create this mystery element. So a lot of some questions that arise from this activities are, what do the sticks represent? What do the numbers on the cards mean? Why does reactivity increase down a group for metals? Why does reactivity increase down a group, decrease for nonmetals? Why is the last group completely unreactive? Why do atoms get larger going down the group but smaller across a period? So we're going to have to answer these questions, but first we need to learn atomic structure, which is where we'll be heading to next time.